Okay, so the first couple were quadratic formula. And then we need to find a polynomial with degree 3 that has the following zeros. They're being really nice to us because they say we can leave it in factored form. They didn't say that. This turns into an ugly problem. So let's rewind for a minute. This has nothing to do with what that problem is. But if I had, let's see, x squared plus 6x plus 9. How does that factor?
3x squared, x plus 3 squared.
X plus 3 squared or x plus 3 times x plus 3, same thing. So what are my zeros of this function? -3 repeated, right? So we're familiar with this. You look at this and you tell me a 0 is -3. So using that information, we want to come up with a polynomial that has the 3 listed zeros. So what would your factor look like if 8 is a 0? Wouldn't it have to say x minus 8?
Yeah.
How about the 5, the -5?
Yes, somewhere else.
All right, x plus 5. And how do I get a 0?
Just x.
You could totally put it at the end and it would be fine, but traditionally we see it in lead. Leave it just like that. So those are friendly problems. Let's do one more. We'll do it quickly. All right, we will have f of x equals, how about the 1? X minus 1, how about the 0? How about the 9? And how about the -2? All right, golden. Okay. And these I'm going to do in 2 different methods. So if you like the first method, just ignore me when I do it a different way. And usually I'll go with whatever the class likes best as a majority. So we will soon be learning a theorem that will use this operation. So I figured we better practice being able to FOIL that out. You guys, even though it's big, can you see that I've got a parenthesis times a parenthesis? I look at these guys as the first. And then I look at these as the outside. Oh, this is just too much fun. And then I look at these, oh, it's too close to the red, but as the inside, and then whoop, as the black. So when I'm pulling that first outside, inside, last. And I'll show you a little bit more of what I mean, because that was confusing. X times x for my first. What do you get? All right, outside. I'm not going to distribute anything. I'm going to set it up. So this guy times this. So I've got a positive times a negative. So I'm going to put -x times 5 minus 3x. Now I'm going to move, really. Now I'm going to move to the inside. So that would be including its sign and x. Well, that's a minus x times, in this case, 5 plus 3i, isn't it? All right. And then my last. What's a negative times a negative? And I would have 5 plus 3i times 5 minus 3i. Okay. Doesn't that look like fun? A blast? Loving it already? Okay. So, let's clean it up. Don't let me mess up. What do you remember about multiplying conjugates, and what are conjugates, by the way?
They cancel out.
Cancel out what? Not all the way. What do they cancel out?
The last
The outside, inside. So I want you to look at this. The first is 25, right? The outside is negative 15i. The inside is positive 15i. If you can remember that conjugates cancel out the outside, inside, now all I need to do is multiply the first and the last. What's I times I? All right. If you do something wrong on these, they don't turn into a pretty problem. So if you get something really ugly, you know you did something wrong. That cancels. What else? What does I squared equal? You don't remember? I squared, I cubed, I to the fourth. I know, it's hard to remember. We're questioning it. I1, with negatives in the middle. So what does I squared equal? Negative 1. So I'll use that over here as that is a negative 9 times negative 1, which makes that a positive 9. So let's clean this up then. I've got x squared, that's negative 10x, and I have 25 plus 9 is, all right, you should get a nice, happy, pretty trinomial. You don't, you did something wrong. Okay, that was method number 1. Totally used FOIL. Some people really like that way. Other people, you're still mad at me because we just did it and you hated it. Here's method 2. I'm going to take this negative and I'm going to distribute it. So that means I could have x minus 5 minus 3i. And we're going to do the same thing here. X minus 5 plus 3i. Setting it up this way, I have a triple distribute problem. I'm going to take the x and times over there. X times x. X times negative 5. And x times 3i. All right, that's done. I'm still going to run out of room. I'm not writing small enough. Now we're going to take the negative 5. We're going to do the same thing. Negative 5x plus 25. I lost where I was. Did I miss something? I didn't? I feel like I did. All right, inside. Not inside. We are, we're going to do the color, orange. We're going to take the negative 3i. Let me write it, right here. Negative 3xi minus 15i plus 9i squared. I feel like I missed the sign. Something didn't cancel. Negative 5. Who knows where it is?
Isn't it plus 15?
Which one? This one?
Yeah.
Negative times negative. Thank you. How did I know I made a mistake? What did I already tell you guys? It's going to clean up pretty, and I ended up with some i's that weren't canceling out. So thank you for helping me figure out where I missed my sign. So now I can go through here. Those cancel. Those cancel. Is that the I squared again? All right. I squared is, oh, and that would have been a negative, by the way. You guys tell this is not my preferred method of choice. I messed up signs. All right, so that's a negative 9 times I squared, which would give me a positive 9 right there. There's x squared minus 10x plus 34. Is that what we got a second ago? Okay, so I know we've only done it both ways once. But who would prefer to FOIL? Curious. Who would prefer to triple distribute? Who hates both ways, but they're willing? All right. Okay, and then the last 4 or 5 problems are just reminding you how to factor still. We're keeping that in the loop. So, good luck, good luck.
Can we do a journal for yesterday?
Good question.
Did indeed, Saturday. Did indeed.